All right, we're going to resume Advent of Code 2015, Day 7. Thanks for joining me, everyone. We are going to see, so here's where I left off. I was able to completely parse the input. I struggled with some regular expressions to parse, stuff like this. But in this case, we should should be in good shape. So I'm looking at this stuff, I think I'm gonna, what is output Y? So I'm gonna start by updating my test case here, because in this case, what we have is, we're supposed to return the output of A, but my test input doesn't have an A wire, so D, E, F, G, H, I, X, Y. So I think I want to pick one of these ending to either H or Y. I'm gonna pick I. I'm gonna change I to A, and then the value of I is 65079. So if we go like this, and then I'm going to do another test case here. I'm just going to copy and paste. And this one, I'm going to make that I, and this one A, not X. Or no. Let's do G. G is 114. Okay, hopefully that works. Okay. So now now that I have parsed the rules, I've parsed all the rules out, I need to create a circuit board with the rules on it. In fact, I'm going to need to do var rules equals an array of rule. And that's going to start, we're not going to initialize it. We're going to initialize it in an initializer. Init rule, rules, rule. Should be plural, rules. Self.rules equals rules. Okay. So we're going to have a function here, and the function is going to have to, so here's the way I think that we're going to have to do this. We need to find the output of wire A. And in order to find the output of wire A, we have to find the rule that outputs wire A. And from there, we have to work backwards, right? So for instance, in this case, if I were to find the output of wire A, first I have to find Y, our shift 2. So first I need to find the output of Y. So where's Y? Oh, it's right here. 456 is assigned to Y. So that's how that's going to have to work. We're going to start with, so now that we have all of our rules, we have our wires, and then we have to, actually, do you know what? I don't think this, I think it's going to be deterministic. So I don't think I need this array, this dictionary of wires, right? So we're going to be able to have a function here that looks up the value of a specific wire, and then we're going to call it recursively for all the wires that we need. So we're going to compute signal on wire name string. Okay, so, and this is going to return an integer. So from here, we need to find locate rule for output wire name, and that is going to return a rule. And so we need to do rules.find first where the rule 0 dot output wire equals wire name. Okay, so that's going to return. I'm going to give that an optional, but I'm going to give it the bang because I think it's almost certainly going to be truthy. I mean, we're going to be populated. It's rare that it would not be popular. It should not happen with this input. If it is returning null, that indicates a failure with our code. Okay, so from compute signal, we're going to get the rule equals locate rule for wire name. Now that we have the rule, we need to look at the operator. So we're going to switch on the operator because it's a switch. I mean, it's an enum. So we're going to switch on the operator. Switch rule dot operator. Op. Okay, we're going to give it a bang. Here, case dot. Okay, so in the case that it's an assignment, let v, we just have to return v because there's no computation to do. That's all we need to do. We're all in good shape. Okay, so in the case of not, we're going to do let v. So this we're going to return, I think it's dash v, because v should be an int. Correct? Not as a string. Oh, right, because we need to compute the value of the wire. Okay, so return Here we're going to go return compute signal on V. That's what it is, because in this case, wire. On wire. Right? Because the NOT is going to operate on a wire, so we have to return this minus compute signal on wire. And let's just double check that minus is the NOT operator for a bitwise, right? Bitwise NOT is minus A. Yes, okay. All right, next one, let's do an AND, case.AND. We have let wire 1, let wire 2. And in this case, we're going to return compute, let V1 equals compute signal on wire 1, and let V2 equals compute signal on wire 2. And now we're going to return, it's V1 and ampersand V2, okay? Case.or, or, and we're going to let wire 1, same thing, let wire 2. We're going to let V1 equals compute signal on wire 1. Let V2 equals compute signal on wire 2. We're going to return V1 or V2. Case dot, what am I missing here? R shift and L shift? Okay, let wire int let V, let V2, I guess is what it is. We're going to let V1 equals compute signal on wire. And then from here, we're going to say return, this is R shift, right? Okay, so we need to do the double ampersand. So V1 double ampersand V2. I mean double caret V2. Oh, no, we just have to return that. Case L shift. Let wire and let V2. Same thing, let V1 equals compute signal on wire. Return V1, V2. Okay, am I missing anything? There was 6 instructions. 1, 2, 3, 4, 5, and 6. Okay, does this build? Unary operator cannot be separated from its operand. Like that? Okay, did you lie to me, programs.com? I think programis.com lied to me. Okay, so now we have compute signal on wire name. This should be simple. I should just have to, now that we have our rules, we're going to let circuit board equals circuit board rules. We have our rules. Okay, and we're going to do let A equals circuit board dot compute signal on wire A, and we're going to return A. Okay, I think this should solve it. So let's take a look. Okay, compiling, here we go. Our first test case failed. Expected actual, minus 456. Now, how did that happen? Okay, so what did this indicated that, in this case, A is going to be I should be 65079. And this was not the case. 1, 2, 3, 4, 5, 6. Okay, so I is not Y. Y is 456. Oh, wait a second. Because this is not... That's a negative. Is that what happened? Is my not... I bet my not logic is incorrect. What did it say? Expected actual negative 456. Okay, so it looks like I just multiply it by negative 1, which is not what we want. Okay, hang on a second. Bitwise not. What is this character? Is this not a dash? Is this not a minus? Maybe it's like... Oh, that's a tilde. Oh my gosh, that's a... Look at that. It's a tilde. Program is. You destroyed me. Okay. Choose a better font. Okay. Let's try this again. Okay, it still failed. Why did it still fail? Did I not save? I got the exact same output. 65079. Yeah, okay, I did that. Compute signal on wire. Let wire. Okay, let's try it. Why is it still giving me negative 457? That doesn't make any sense. Because it's got to be an unsigned integer. Damn it. Of course. Oh my god. What if I... Okay, so what if I parse this as an uint? What happens now? No. What? Negative value is not representable. Oh, weird. Okay. Okay, so I need to... Shit. Okay, how do I do this? I guess I need to have a function that normalizes the output. So it's going to loop until it's above 0 if it's within bounds. So if it's too high or too low, then we loop until it's within range. That's what we're going to have to do. Func normalize output. And that's going to be an integer. And then if output is greater than, what was the maximum amount? Here we go. If it's greater than, then we're going to normalize return. It's going to run recursively. Return normalize output of output minus. Okay. And then else if output is less than 0, return normalize output plus this some number, else return output. So we don't have to loop anymore. Okay, we don't have to run recursively. So we're going to do normalize missing argument output. Oh, okay. Okay, so now we're going to try one more time. Hopefully this works. Oh no. Why? It's off by 1. How am I off by 1? 65535. If it's 65535, then we subtract that number. No, because that's the maximum number. Okay, so we need to add 6. It needs to be 6. 65536. So if it's 65535 is valid, but if it's greater than 65535, it's greater than 65536. No. Yes, if it's greater than 65535, then we have to subtract 65536 because that means it's got to be, yeah. Okay, now let's try. 65535 is a valid input. There we go. Okay, so now I'm outputting. Uh-oh. Fatal error. Unexpectedly found nil while unwrapping an optional value. What's going on? Where did that occur? It must be, let's see here. Locate rule. Here, it must be this. Must be that locate rule. Okay. Print locating rule. I'm gonna wrap it in these colons because there might be like white spaces that it's screwing me up. Wire name. See what happens. Okay, I don't understand why where am I printing the... Is it that? No. My test case is obviously passed because otherwise... Oh, here. So it's like it's bombing out on the very first test. Unexpectedly found. Okay, so it's not even locating. Okay, here we go. Locating rule A, Y, A, Y. Okay, solving A. Unexpected fatal error. Unexpectedly found nil while unwrapping an optional value. So literally the first the first rule, right? Solving. No, there's got to be something else. Map, circuit board rules. Okay. Locate rule, locating rule. So it's not even getting this far. Because it should say locating A, locating rule A. It should be the first line. And it's not even getting that far. So what's going on? Compute signal. Okay. On A, circuit board, initialize circuit board. Okay, there's nothing suspicious there. Rules input lines map rule init. Okay. So there's something wrong with my parsing logic? Could that be what's going on? Okay, let's try this. Print parsing descriptor print parsed. Parsed. Okay, and it's still found. What is going on? 106. Oh, delete breakpoint. Groups input parser descriptor. Parsing. Oh, print parsing descriptor. Parsing operator. So I must be getting some input that is not being validated by my regular expression. Parsing operator. Okay, operator. Okay, what's going on here? Parsing operator 1x. Oh, shit. See, so that's an assignment. This is the one time assignment is not an integer. Interesting. Oh, damn. Okay. We need to have another case. Case assign wire. Int. Okay. So, L shift, R shift, not. So I'm going to add it to the end of our little regular expression here. And let's see here. If it's not, oh shit, it's just going to be letters. Okay, so it's just going to be, that. But instead of digits, it's going to be letters. It's going to be word characters. So this will be the first assign is going to be assuming if let assign in string. Okay. Else if let assign wire equals groups 10 self equals dot assign wire. Okay, and return. I did not anticipate that. That's actually very interesting. Okay, so we assign the wire. Oh, and this should be a string, not an integer. And now assign, and we do case dot assign wire, let wire, and we do return compute signal on wire. There, that should do it. Let's try again. We got it. We got 65535. That's suspicious. What happened? Is that correct? That's not the right answer. Your answer is too high. What happened? Okay, I can take off these parse. Okay, I'm going to update my test cases to make sure the math is all working out correctly. So we're going to do... Okay, so first we want 1, 2, 3. 1, 2, 3, X. So I'm gonna make, no, let's keep that one, the not Y. Let's make that one, and then I'm gonna move this one up. Actually, here's what I'm gonna do. I'm gonna put these at the beginning. I'm just gonna test every single rule. E, F, what is that, G? Yeah, that'll be G, A. 1, 2, 3. And these are gonna, well, it should probably pass even though it's, yeah, so A, yeah, X is 1, 2, 3. Okay, and then this one, this is 4, 5, 6. You know what, I don't need that. I don't need that bullshit. Oh, shoot. Okay, let's do A. Okay, X and Y. So that was D. D should be 72. Okay, now X or Y. 72. E is 507. I'm not worried about, let's just, to clean it up. E, F, G. G, okay, yep. A, Y, and then X obviously is no longer valid, but it won't even get that far. I hope. It shouldn't get that far. Okay, 507. That was X or Y, and then we're gonna do the L shift. 2 is F. 492. Okay, and this one, we want the not operations. EFG. Let's do this one. X. So H. Okay. Okay, it still passes and it still returns 65535. How is that possible? Okay. I don't need these printing operations anymore. I'm stunned that 65535 is not the correct answer. How could that be happening? Compute signal on wire. Okay, we know that the last thing that we know that LX, locating rule LX. So let's look at LX. Let's see what that's about. Locate output. Oh, no. LX. Okay, but in order for this to pass, like, all of these are now gonna just be bunk. So we're gonna go like that. Okay, 65535, that's what LX is, which I knew that already. Now what is LW? I might have to, like, take a closer look at my test input too. LW. $65534. LW. L shift 1. Okay. What is LC? Compute signal. I guess I want it to, like, I want to be able to see what the actual value that was returned was. Locate rule output. I don't understand what's going wrong here. Okay, here's what I want to do. I want to have let return, I'm going to start at RET, and that's going to be an integer. And I'm going to RET equals V, RET equals V. Instead of returning, I'm going to say RET equals, RET equals, RET equals. This will help me debug it. RET equals, RET equals, RET equals. I'm going to do print wire name arrow RET, return RET. Okay, solving A. Wire C is 0. Wire LW. Do print assign V. This is going to be assign wire. Not wire. No, but they're okay. Print and wire 1 and wire 2. Maybe I misread the puzzle. What out signal is ultimately provided to wire A? I don't understand what I'm doing wrong here. Let's try it. I mean, I'm going to keep going here with this printing because this will help me debug. Print, oops. It's going to be R shift. Print, no. L shift. V2. Okay, wire 1, wire 2, wire 1, wire 2, wire, okay. Nope, this is wire. What? Wait a second. Something is not right. Why is it assign 1 every time? What's happening to the other... Where are the other... Oh, here we go. Yeah, assign wire, LX. Okay. And then it's drilling down. T or S, C, L shift 1. C is 0. So wire C is 0. Wire T is also 0. Wait a minute. What happens when you L shift? No, that's what... Okay, so wire T... No, this is not correct. If I L shift 0, that should not be... If I... Oh, no. Okay, now hang on a second. Let me check. Swift 0, 1. 1, 1. That should be 2. Okay. And then 1, 0. Is that nothing? 2. That should be 4. Okay, so yeah, that's actually correct. Okay, never mind. Okay, L shift 1 is T is okay, now what's S? What is this? Assign 1. Okay, S is 1. That means U is 1 or 0 is 1, right? No, T or S, right? So S is 1. Wire U is L shift 1. U L shift 1. Okay. Wire AO is 2. Assign 1. Is there something wrong with my... I'm always assigning like 1 or 0. Which maybe that's normal? Wait a second. 1 and DS. That is a 1, right? That's not an L? That's a 1. Oh, shoot. Yeah, see, 1 and KZ. Oh, no. Shoot. Okay, so I think each one of these has to be a... You have to refactor this. See, I made an assumption. See, I knew this was going to bite me. I made an assumption that all of these values were either going to be, so like the OR is always going to be 2 wires. L shift is going to be a wire and an integer. R shift is going to be a wire and integer. That turns out to not be the case. I'm looking at some of these. I see here, like this one right here. 1. That's a 1 and KZ is LA. So this 1 is not a wire. There is no wire 1. If I go like this, there is no wire 1. So how is that resolving? It's not. So it must be returning 0 or something, right? I don't understand how that could possibly work. Okay, so I have to refactor this a little bit. So now I have to create a new, a box or something like that. That's like, or maybe I just make everything a string. And then I parse it in my parser here, right? And I say resolve, you know, like in compute signal on wire name. If wire name is a number, then we just return the number. Let's do that. That's what we're going to do. Okay, assign. So I no longer need this assign wire function. And this is now a word character. So it can be either a digit or a word character. Doesn't matter. I don't need this one anymore. And I certainly don't need this. So word character, so that a word character could be any letter, any sequence of letters or numbers. Okay, I no longer need this step. So assign in. And assign string. And then these are also, you know what, I'm just gonna make them also strings because I wanna make things nice and even. Okay, groups and okay, good. L shift, here we go. L shift 1 and L shift 2 string. So nope, this is just L shift 2, and I'm going to delete this. And then R shift. Okay, and we're gonna say R shift. Okay. That should be good. I'm no longer trying to parse integers. So let's see what happens now if I go like this. If I uncomment this, it should still pass. Okay, what assign? Oh, right. I no longer have this assign wire. Okay, yep. I can delete that. Okay, this is not going to work because I'm operating on strings. So what I need to do is I need to say the wire name. First thing I need to do is assign wire name if let v equals integer of wire name. I see, wire name. This needs to be right at the top. Then we return v. Right? So compute, locate rule for output, and the return value. Assign. So this assign, this is going to be a string. So what I need to do is return compute signal on wire. So this assign value could be a 1 or it could be a 0. Or it could be a wire. It could be a 1 or a wire or a number or whatever. And if it's a wire, then we're going to compute the signal. If it's a number, then this is just going to return immediately. And then it won't even get to this part on the recursion. Okay, so let's try. Yeah, okay, so again, wire, there's got to be wire, this has got to be wire 1 and wire 2, just like all the rest of them. Wire 1, wire 2. Same thing, wire 1, wire 2. Okay. V1, let V2 equals compute signal on wire 2. And wire 2, wire 1. Weird that the original output just immediately was going to be 2. Like, that was such a coincidence, and I my senses were right dead on that was not the correct solution. Okay, wire 1, wire 2, wire 1, wire 2. Okay, this should be good. Nope. What did I miss? Oh, oh yeah, this should be wire. Assume everything is a wire. Okay, see, now what? Now everything is 123. What happened? Actual 123, actual 123. It's A. Okay, 123, wire A, 123. Okay, wire A, 123, assign in X. Now why is that failing? Okay, assign 123, assign X, assign 123. Okay, 0 passes. Assign 123, wire A is 123. So okay, and the second one, assign X. Wait a second. I know what I did wrong. I need to go back to debug X. The problem is what was happening is the, do I have the other one open still? Damn, I do not. Okay, so if I go to, what's happening is it's short-circuiting on this first option, right? This word character. And it finds, you know, the first word until it gets to a space and it's like, oh, I guess that's it. And it stops. So instead, what I need is to indicate that this is only valid if it reaches the end of the string. So I'm going to have to probably wrap this in a non-capturing group like this. And then the beginning, how do I do beginning and end? Beginning of the string is a caret. Okay, caret. Oh, I know. Let's do this. Caret, and then at the end is a $sign. Let's see if that works. Nope, still the same problem. Okay, what if I do caret and $sign? Ooh, wait a second. Here we go. Now we're talking. All right, this is more promising. I think I need to log way less. I hope this is not like stuck in an infinite loop. One thing I could do to optimize this a little bit more is cache the outputs of these wires. Because if we find out that I'm trying to access the same wires over and over and over again for like multiple, it's like, you know, if one wire is used in multiple inputs and we're like trying to compute it over and over and over again, it would go much faster if those values were cached because it's deterministic. It's not going to change from one input to the next. I'm beginning to get a little bit suspicious about this output. Well, it looks like the input letters are getting smaller, or they're getting closer to the beginning of the alphabet. I feel like I'm seeing fewer. Let's see here. K and M, G and I, okay, E and F. Okay, while that continues to run, I'm going to start writing the caching logic. So to var, I'm going to do private var cached. Cached values. String int. And then compute signal. On wire name. We're going to capture wire name, and we're going to do cached values on wire name equals ret. And we're going to do if let cached equals cached values wire name, return cached. Otherwise, oh, right, if it's an integer, then we don't even need to do a wire lookup. We'll just return that. Okay, cached values. Damn, Bobby Tables. You were expected to solve this? I don't know, I'm starting, my sense is something seems fishy. Something's not right. Okay, wire, okay, cache it. If it's cached, then we return the cached value, otherwise we locate the rule. All right, that should be all that's needed. What? Oh, I never initialized it. Boom. Wow. Okay, that's all it took. It was just doing so much recursion that it tripped over itself. But as soon as I started caching the outputs, then now it's looking good. Okay. Answer completed in less than 1 second. Boom! That's the right answer for part 1. Caching was the solution. I'm shocked that there was so much recursion happening that simply caching the values caused it to go from like, I don't even know how long it would have taken, maybe 10, longer. It already took a couple minutes. And then once I add the caching, it solves in less than 1 second. Wow. Okay. So, moving on to puzzle number 2. Part number 2. Now, take the signal you got on wire A, override wire B to that signal, and reset the other wires, including wire A. What new signal is ultimately provided to wire A? Aha! So now, take the signal you got on wire A, override wire B to that signal, and reset the other wires, including wire A. So here's how I'm going to do that. Now, I don't want to mess around with the puzzle input. I don't like doing that because then it screws up my whole code base. So instead, what I'm going to do is I'm going to copy and paste this into puzzle number 2. My test cases, I don't have any test cases for part B. But now that I have my rules, so what I'm going to do is I need to mutate the rule that has that assigns to B. So I need to find the rule for output B. So we're going to find rules.output so we're going to do B rule equals rules.find at first where maybe I can just use the circuit board. That's an idea. I'll just manipulate it right on the circuit board. So circuit board dot locates rule for output B, and my rules are structs. Here's what I'm going to do. I'm actually just going to add a function to my circuit board. Func override rule for wire name. New constant, new output int. And I'm going to go like this, and I don't need to do anything. And so now I just need to find let I equals rules dot first index first index where dot output wire equals wire name. And then, this has got to be an uppercase. Well, it doesn't have to be, but I'm going to make it one because I'm like that. Okay. And then we're going to do rules I equals rule. I don't have an initializer, like a normal initializer. What the hell? I'll just use a descriptor. I'll type it out. New output arrow wire name. So we're just changing that. That should be it, right? That should work. So now we have our circuit board. We're going to say circuit board override rule for wire B, and the new output is going to be the output from A, 3176. I'm just going to type that in. If I wanted to be fancy schmancy, I could, do solve A and do that, but I'm not going to bother. Okay. New output, and then compute signal on A. So at this point, we haven't actually run any computations. We've just located the rule. We've replaced it. Let's see what happens. Okay, is that it? 14,710. Yes! Boom! Fastest part B. Fastest part 2. Beautiful. That's the right answer. 1 gold star to closer powering weather machine. You've completed day 7. How about that? So what tripped me up? So one thing was this dumb tilde. That tripped me up pretty bad. And I blame the font on this website for making me think that was a dash instead of a tilde, which in hindsight, I should have immediately caught on that was not a dash because that doesn't make sense. Another thing that tripped me up was, the regular expression. So when I wrote this, I anticipated, I guess sort of assumed that it would start at the beginning and the end, and it would try to find a fit. Like it wouldn't choose this one unless it fit the whole string. I think I probably could have, another way I could have worked around this is by putting this particular option at the end of my list of regular expressions. But if I had done that, then I would have had to go back here and update all these different groups, which I did not feel like doing. So in the end, I did a caret, I did a $, which indicates start of the string, end of the string. And the only thing that would fit is if it was nothing but word characters, which is, letters and numbers from the beginning and end of the string. And that is ultimately what put me on the right track. Oh, and then the caching, the performance of this algorithm, shocking to me that there was so much recursion that the function would have run for who knows how long until we actually got a solution. So that is also quite interesting. So I think that does it for today. Thank you all for joining me. That was it. Advent of Code 2015, day 7. Let's take a look at our Christmas tree. Go back to my Advent calendar. Look at this. Okay. So now we have our nice little, it's lighting up. Oh, I can't wait till we reach number 5 and get the star on the top. All right. That's it. Thanks for joining me, everyone. I'll catch you all tomorrow.